In this problem, they have given the stringers area and E Young's modulus, yield stress, and determine the total compressive load. They have given the top view and the front view of the diagram. This is the sheet, and these are called as stringers. So what are the formulas to find the total compressive load? And here, if you see, this is this whole section compression. It is compressed due to this load. Compression is occurring. So the formulas used is P is equal to sigma C times A. For finding sigma C, K into E P by B, thickness by breadth whole square. Now first, when sheet and stringers simply supported on all four edges means A will be 70 mm, B will be 6 mm, T will be 1.2 mm. So if we divide A by B, it will be 11.6, 70 by 6. So here B will be 6 centimeter. All the sides will be supported by on 4, simply supported. So we will get A is equal to 70, B is equal to 6. For A by B is equal to 11.6. How to find the value of K? There is a graph for that. See, in the graph, x-axis will be A by B and y-axis will be K. For this particular value, how much the K value is? So we got 11.66. So 11.66 means 3 root 12 is around 10.392. So 11.66 will be around here. This 4. This is the 4 value of 4. K value will be 4. It will be around slightly here. So we can assume as 3.6. K is equal to 3.62 from graph. Now sigma C is K times E T by P the whole square. So K we got from graph is 3.62. E they are given 70 GPa gigapascal. So 70,000 T by B. Here B is 6 centimeter. So we want to convert into mm. So multiply by 10. We will get 60. And thickness is 1.2 mm. So we will get, after substituting all these things, we will get sigma C is equal to 101.36 MPa megapascal. Suppose if 3 edges are simply supported and one edge is free, then what will happen? See, the breadth will be 1 centimeter. Here there is no support, but so the B value will be 1 centimeter. The rest remains the same. A will be 70 centimeter, B will be 1 centimeter. So A by B will be 70. So from the graph, K will be 0.385. So substitute the values in sigma C, we will get sigma is equal to 388 MPa. So for finding area, okay, so 14 into 1.2, the whole length, okay, this will be 6, 1, 6 plus 6 will be 12, 12 plus 1 will be 13, 13 plus 1 will be 14. So times the thickness 1.2. Here this centimeter, see centimeter, so we need to convert into mm, so multiply by 10. So 14 into 10 into thickness, okay, plus the area of the stinges, okay, they are given 0.7 centimeter. We have 3 stinges, okay, so 0.7 centimeter for mm conversion, will get 0.7 into 3 times 100. So area will be 378 mm square. So compression load, okay, sigma C times A. Sigma C we found out that 101.36, okay, substitute in this 101.36 into area 378, we will get 38314 Newton. Okay, now the effective width, for finding that width 0.85 times thickness root of E by sigma C. This is the formula. Okay, we know E and sigma C. Okay, now substitute here the values and 6, and we will get 16 into 1.2 mm. Here in the question they gave 2 conditions. First, find the load P. Second, when sigma C is equal to 200, find the effective width and load for particular effective width. Okay, so sigma C they given for second condition 200. So if we substitute here, we will get 16 into 1.2 mm. So for W1, rest will be same, thickness E by sigma 2. Here 0.85, here 0.6 will be there for formula. So how to calculate effective area for a sheet only? Okay, so this is the formula, 4 times W plus 2 times W1 times thickness. So we got the value of W1, we substitute here 4 times W plus 2 times W1 into thickness we know 1.2. Okay, after substituting we will get 124.3 mm square. So this is the area of sheet. So if we want to find out the total area, okay, so suppose we want to find the total area, so we want to find the area of sheet plus area of stingers. So we found the area of a sheet, so stingers here. We have 3 stringes and we know area. So 3 into 0.7, it is in centimeter square. For converting mm square into 100, so we'll get one area. So load, compression load P is equal to sigma C times A. So then we know they gave sigma C as 200 times the area, we will get 334.3. Suppose if they can ask, find the ultimate stress, ultimate load. So they given yield strength is 280 MPa. Okay. So after finding that yield strength, if see in this, instead of 101, if you substitute this yield stress 280 MPa, we will get the ultimate load, ultimate compressive load. That's it.